In this series of videos, we're going to focus on generics. Now, we're first going to talk about using generics in the most common way that we use them, which is using generics with the collection classes of the Java Standard Library, essentially the classes of the collections framework. So generic programming in general allows you to write classes that can be used with objects of different types. So this is essentially designed for classes that are collection classes or data structures like lists and stacks and queues and structures like that. And generic programming allows you to write classes like this that can be used with objects of differing type. So you can write one single list class, and then you can create a list object that holds integers, or another list object that holds strings, or another list object that holds students or employees, or any other type of object that you want. The idea is that you write one class, and then the type of object that can be used with that class can vary when you create objects of that type, of that class, I should say. So essentially, we're allowing type to vary. We're allowing type to be a parameter when you create your object. Now, we usually think about parameters as related to methods, right? When we declare a method, we have formal parameters. Those are the ones we write in the method header, and we use those formal parameters inside the method. And when we invoke that method, we pass actual values into those formal parameters. So when we invoke the method one time, we'll pass certain values, and when we invoke the method another time, we pass different values. So generic programming, it works on those same ideas. The idea is that instead of varying the values we're sending in, we're actually varying the type of object that we're sending in. So again, one time we can create a list that holds strings, and another time we can create a list that holds integers. So the type is what's varying. In Java, generic programming allows that type checking to happen at compile time. So it's always a good idea whenever possible to move all our error checking over to compile time. It's much easier to find and resolve errors at compile time compared to runtime. So anything we can move to compile time, we want to be able to do that. And that's what generic programming allows you to do, is it allows you to have that type checking happen at compile time. So here's some simple examples of creating objects, generically typed objects using the Java collection classes. So you might create an array list that holds strings, an array list that holds integers, or if you were writing a GUI program, you might create an array list of buttons or a linked list of strings. So in these examples here we have one class, the array list class, but we can vary the type that's being held in that array list. So we can create an array list of strings, an array list of integers, an array list of buttons, and so on. So again, what's varying here, what the parameter is the type itself. Now, generics wasn't actually part of the original Java language. It was introduced in Java version 5. So it is possible to use the collection classes without generics, but you really shouldn't do that. This is what it would look like, and it is possible that you will see code like this. If you're working with legacy code that was written prior to Java 5, it's possible that you will see this kind of code. However, you really should always be using generics when you're writing your own code. At this point, now that we're up to Java 9, you should always be using generics. I hesitate to ever say never, but I really struggle to come up with an example where you shouldn't be using generics with the collection classes. You really always should be specifying the type when you create a collections object. But this is what it would look like without generics, and this is what it would look like prior to Java 5, before generics were introduced. So you would create an array list, not specifying what type it can hold. So this was now just create a raw array list object, and you could put any type of object, capital O object, into this array list. Now let's say you intended to create an array list that just held strings, right? You want to create a word list. That's what you want. Well, you can certainly do that. You can add strings to your list, but you can also add an integer. So there's nothing stopping you from doing that. There's no check to make sure that you're only adding one type of object to your list. So without generics, you can just add anything you want to the list, any object, right? So that's a real drawback. That's a downside of not using generics, is that there is no type safety. You can add any kind of object you want to that list. And now if you want to get things off the list, well, the compiler only knows that the list holds objects. It doesn't know anything more specific than that. So if you know in your mind, you think that this just has strings in it, and you want to get all the strings off of it, you have to iterate through and you have to check if, that should say my words, if each element on the list is an instance of a string, and then you have to cast it to be the string. So you have to do this manual type checking, and then you have to do this cast to say, nope, this isn't an object, it's a string. And then what happens is, you've actually now missed an element on your list because you had an integer on there. So it can be kind of a mess, right? You have to do this checking and this casting, and it's not very clear, very clean, I should say. It's not easily to maintain. It's very error prone. So you definitely don't want to be writing code that uses the collection class without generics. But this is what that would look like and what it looked like prior to Java 5. Now with generics, what you do is in your declaration statement, you just add the generic typing. So you add the little caret brackets here and you put the type inside of that. So here we're saying we're creating an array list, and our array list is going to hold string objects. You also put the caret brackets on the right-hand side on the initialization statement. So they go on the declaration side on the left and on the initialization or instantiation side on the right. Starting as of Java 7, you can leave the word string off if you want. So you can either repeat it, put it in the declaration and in the instantiation on the right, so on the left and the right, or you can leave the word off, but you cannot leave off the caret brackets. So be really careful about that. You always have to use the caret brackets, so don't leave those off. But starting in Java 7, you can leave off the word, so that would just, look like this, array list with just the empty caret brackets. That is allowed. And you'll see a lot of people doing that just because it's less typing. But some people stay away from that because I think they're afraid that if they don't put the type in, they'll forget to put the caret brackets in. And you definitely need the caret brackets in. So just be aware of that. So what this use of generics does is it puts a compile time check that only strings will be allowed to be added to the list. So we can go ahead and add our strings. If we try to add an integer, we'll get a compiler error. So this line is no longer going to be allowed, and that's what we want. We wanted our list to be restricted to only holding strings. And there's now a compile time check on that happening. So that's a really good thing. Again, we always want to check things at compile time whenever possible. So compile time type safety checking is the best benefit we have from generics. It's great. It's a really good thing. The other nice benefit is we don't have to do any casting. So when I want to take things off my list, well, the compiler already knows that the only thing that was allowed on the list was a string, so it knows that the only thing coming off the list is also going to be a string. So I don't have to do any manual type checking. I don't have to do any casting. I can just take that object off my list, put it right into a string because the compiler knows that's what it is. So I can only add the desired type to my list, and when I get things off the list, I don't have to do any type checking. So that's great. Two really nice benefits of using generics. Another little side benefit is I can use the for each loop with string being the type used inside the enhanced for loop or the for each loop. So that's a nice little benefit. I know that this array list only holds strings, so I can use that type in my for each loop. So again, whenever you're using the collection classes, you want to be using generic typing and specifying what kind of object is going to go into that particular collection. Now, this was a very, very brief overview of how to use generics with the Java collection classes. I'm assuming that most of you, now that you're at this level of programming, have done this many times, and you're pretty familiar with using this type of generics in this way, with using it in specifying what kind of object is going to be held by an array list or a linked list or whatever the collection class is. So that's why I go through this pretty quickly. However, if you are not as familiar with this, or if you need a more in-depth refresher of this, then I'm going to strongly encourage you to pause this video, and on the instructional content page I put a link to my more in-depth video from 111C where I actually walk through a couple of coded examples and eclipse showing you the use of generics with the collection classes that I just went through kind of quickly. I go through them in more detail. So again, if everything I've gone through here now is second nature to you, you get it, you totally have done this a million times, then you can just move on. But if you need a little bit more of a refresher, or it's not as familiar to you, please do pause this series of videos, go watch that single video from 111C, and then come back, and hopefully that'll be enough of a review to move forward into the more in-depth topics we're going to cover. Okay? So there are two main ways that we use generics, and the first is as a client of generic classes, and that's what I was just discussing. So the Java collection classes, the collection framework is written with generics, and when we use those classes, so When we use an array list, for example, we are acting as the client of the array list class. And to do that, we're using generics, right? We're specifying that, yeah, my array list holds integers, or my array list holds strings, or my array list holds employees, or whatever it is, right? So we do this all the time. It's very, very common that you are going to use generics at this client level of using it with the Java collection classes, right? So the good thing about that is that it's relatively straightforward. It's pretty easy to specify what kind of object you want to put in that collection, and to then, you don't have to do the casting anymore. It's pretty straightforward to do, and it's really common to do, so that's good. There's another way to use generics, and that's as the actual developer of generic code. This is not as common. So it's not as common that as many people write their own generic classes. It's a little bit more common that people write their own generic methods, and we're going to look at both of those things. So this is something that maybe you won't do as often, but it's still an important thing to understand. And so that's what the rest of these these video lectures are going to cover, is actually us working as a developer of our own generic code. So again, using generics as a client of the collection classes, very, very common, but also very straightforward. Hopefully that's pretty clear to you. Again, if not, pause this video and go back and watch that other video that I've provided a link to on the instructional content page. But this is something that we do all the time. What might be new to many of you is the idea of writing your own generic classes and your own generic methods, and that's what we're going to get into in these videos. Now, I did want to just make a little bit of a warning that this stuff can get kind of complex, especially when we get to some of the later videos talking about bounding and wildcards. It can get it gets a little complex. It can get a little abstract and hard to think about. So just be aware, kind of just always try to bring it back to sort of simple examples. And those are the kind of examples I'm going to try to show you, and kind of always relate it back to that. It can help you kind of keep it straight in your mind. And just be aware that you actually can just totally go down a rabbit hole with this stuff. If you really start looking into the really fine nitty gritty details of generics, it gets incredibly complicated. So just forewarning, for those of you who want to delve into that, go for it. But just know that you can really go down a path there and spend a lot of time learning these details. And for most of us, for the kind of programming we're going to do in our everyday career, our everyday world, everyday life, you don't need that level of understanding of the total nitty-gritty details of how generics works, okay? So I'm going to try to give you enough knowledge that you should be able to accomplish the task that you're most likely to encounter related to generics, but just be aware that there is more lurking below the surface there. And again, if you want to kind of delve into it, you're welcome to do that. And just, be forewarned that it gets very complex. Okay. So there is your warning label for the rest of these videos. And that being said, let's get started looking at writing our own generic class.